And in today's lesson, we're going to be diving into Module 1, our first lesson in discussing the Linux boot process. So upon completion of today's lesson, you'll be able to understand the boot process objectives that are going to be covered on the exam, and we're also going to talk about the steps that are involved in the Linux boot process. So what will you take away from this module? Well, this module will help you understand boot failures and boot issues you may run into on a Linux system. You're going to need to know this information for the Linux Plus exam, of course, but it's also very helpful if you're working with physical Linux systems. The boot process and files, commands involved in Linux boot are all things we're going to touch on, and we're going to use that information to troubleshoot boot or modify and update boot files. And please take this to heart. Linux boot process is a frequent topic in Linux systems administrator interviews. So if you ever happen to be interviewing for a Linux sysadmin position, you will probably find yourself talking about boot issues. So definitely pay attention if that's you, and we'll move forward. So as we go throughout this module, here are some of the topics we're going to cover, and these generally align with the exam blueprint objectives. So in this lesson, we're going to cover the Linux boot process. Then we're going to dive into the second stage of the boot process, and we're going to get into some of the files that are involved, the boot and EFI files. We're going to talk about different boot options in Linux. We're going to learn about the third stage of the boot process. We're going to look into the bootloader files and play with some of the commands you use to boot. And then finally, we'll touch upon what happens when you have a kernel panic on a Linux system. So let's take a brief look at the Linux boot process, a high-level overview, if you will. And as we move forward, we'll get a little bit more in depth into each level of these different processes and steps in the Linux boot process. The first step is the bootstrap phase. The second step here is the bootloader phase, and we can see the GNU Grub bootloader menu over on the right-hand side. The third step is the kernel phase, and we can see some kernel messages being output to the console over there on the right-hand side. And then the final step is the initialization phase. Step 4 is the initialization phase in the Linux boot process. So upon completion of today's lesson, you'll be able to describe the bootstrap phase. We're going to talk about the role of the BIOS in the bootstrap phase. You're going to understand why UEFI/EFI is now used to boot in place of the BIOS, and we'll also understand how PXE works in the bootstrap phase. So the bootstrap phase is the first phase of Linux boot. It's responsible for bringing up the hardware, testing the hardware, and it also finds the location of the bootloader, which is necessary for us to move into phase 2. We're going to talk about 3 bootstrap options in this lesson: BIOS, UEFI, and PXE. So BIOS, which is the basic input-output system, is legacy bootstrap. It was used early on. It's still used on older systems. And after BIOS happens, the system is going to initialize the power-on self-test, or POST. All right, and POST codes are very complicated. There's a lot of different POST codes that you can find. If POST has errors, you're going to hear beeps. Maybe sometimes you'll see an error message depending upon the motherboard. Definitely take a look at BIOS Central if you need any help determining what those mean. But next, the BIOS looks through the list of devices for the bootloader to move on to that second phase. And that's normally referred to as the boot or boot order in the BIOS menu. And what will happen is the BIOS will search the list in order, looking at the devices to try and find bootloader code. What it's actually looking for is the master boot record, the MBR, and that contains the bootloader codes that we use to move into phase 2. Now, BIOS has been deprecated. It's not able to keep up with the modern hardware and advancements that we see today. Can't boot drives larger than 2.1 terabytes. It has a limitation on the amount of memory addressing it can access, and it can only manage a limited number of devices. So UEFI, Unified Extensible Firmware Interface, is the replacement for BIOS. It can boot those larger drives. It can operate in a larger amount of memory space. This is configured in Linux with EFI Boot Manager. UEFI looks for storage on a device with an EFI system partition, ESP. Now, ESP is FAT32 formatted. Generally, you're going to find that at boot EFI, and we'll see that later in this module as we get into those files. But once that ESP is found, you can load an OS or you can load a bootloader like Grub. And if you want to get into heavy-duty detail on UEFI, please see the spec. Now, the pre-boot execution environment, also known as PXE, is used to boot a server remotely. There are two requirements for PXE booting. The system has to have a network interface card that supports PXE, and the system has to have PXE enabled as the boot device. And what happens then is when you power up the system, the NIC tries to obtain an IP address, and then it transfers files over using TFTP, and then the system downloads the appropriate boot image from that TFTP server's pxelinux.cfg directory. So upon completion of the lesson, you will be able to discuss booting from ISOs. You're going to understand different options for accessing that ISO and also understand how systems can boot from NFS. So ISO image is an image that holds the contents of a disk. Having that data in a file format rather than a physical CD or DVD is a much more effective method of distributing data. So we may have files that are 9.9 gigs in size. Good luck trying to fit that on a CD or DVD, right? But in the ISO format, we can download that and use that to perform operations on our system. We can also access the file remotely to install an operating system on a computer. So there are a few methods that we can use to do so. Remote access to an ISO can be made via HTTP or FTP. So using FTP allows data to be transferred bit by bit, and you can use the secure shell, SFTP, to tunnel that across the SSH port 22, secure shell, SSH port 22, or you can also use hypertext transfer protocol, right? You can use a web browser, and that allows connections over port 80 for accessing an ISO. Now, NFS boot is another remote booting method that is using network file systems, NFS server. A computer will boot with a kernel image, or it can get one from a TFTP server like we saw with PXE boot. And next, the system will connect to that NFS server on the network and access that root file system that it needs to boot up. So upon completion of the lesson, you'll be able to, explain how the Grub bootloader works. Now, GRUB actually stands for Grand Unified Bootloader, right? It's not the little creepy crawlies we see over on the left-hand side. It is the legacy bootloader that is used to bring up the Linux OS. And the purpose of GRUB in all bootloaders is to load the Linux system kernel. GRUB operates in stages. And those stages are stage 1. And that is where that bootstrap we saw finds GRUB on the master boot record, and it points to either stage 1.5 or stage 2. Now, GRUB may go to stage 1.5 right after that master boot record sector before the first partition if it needs specific file system drivers. So if you're loading something wacky or you're using an older version of Linux that doesn't have the drivers that you need to boot up that particular file system, you're going to go to stage 1.5. Do not pass go. Do not go to stage 2 before you get that loaded. From there, you will go to stage 2, which is stored on that first partition, and that presents the text menu we saw a couple of times now, the GNU bootloader menu, and that gives us options for selecting a kernel image. Now, the GRUB menu is configured. What we see in that menu is configured from one of two files. It could be in grub.conf or menu.list. The default configuration file is actually boot grub menu.list, but some distributions actually use boot grub.conf. GRUB still thinks it's using menu.list, but really it's linked to grub.conf. We can see on the right-hand side here, if you see in the blue menu.lst, there's an arrow pointing to grub.conf. That's known as a symlink. We'll get into that later as we go through the course. But that is pretty much what we need to know about the menu from here, and we're going to cover the grub.conf file in depth in a few lessons later. Now, the GRUB system allows you to boot up interactively. It allows you to go in and change the way that you're going to boot into the system. And the way that you can do that is by when you get to that GRUB boot menu, you hit escape. And then from there, you can hit the arrow keys to move down in between your lines. You can hit enter to select current line and do all those wonderful things over there. I won't enumerate all of them here to save you some time, but hit pause, look over those. If you have time on your own system, please go ahead and play around with it. So upon completion of this lesson, you'll be able to explain how the grub2 bootloader works. Now, grub2 is the Grand Unified Bootloader version 2, catchy name. It is the replacement for grub. Any version that is newer than 1.98 is grub2. And you can find out what version of grub you're using by running one of the following commands. And you can see on the right-hand side here, we have a Ubuntu prompt and a CentOS prompt, and you can run grub-install --V on Ubuntu, and it will return the result as to what version of grub that you're running. But if you're on CentOS, you use grub2-install -v. And this will be one of the most fun things that you have to deal with when you work with Linux. How do you find out what version of grub you're running? It depends. Get used to these two words. It depends. You're going to hear them a lot. But you can use one of these two commands to determine what version of grub you're running, depending upon what distribution you're using, whether you're using Ubuntu, CentOS, or some other Linux distribution. And in our case, we can see that both of these are running 2.04 or 2.03. That's higher 1.98. So we're running grub2. Now, grub2's menu is a little bit different to configure. There are actually two places that grub2's menu is configured. The first one is an SE default grub, which controls configuration variables, right? So grub timeout, how long does the menu stay up for? 5 seconds in this case. We can also display things about the command line that you see on the Linux system, whether or not you can, recover grub. And then you also get into the grub directory. And that's where you can build customization around the grub menu. And there are scripts in there that are used to build the grub menu by default. Now, if you wanted to change grub2, what you would do is you can edit etc default grub, and you can make the modifications in there. You can also create a custom script, as I discussed previously, in that etc grub.b directory. But once you make changes to grub2, you don't get to just save them and everything is hunky-dory. You have to go and execute a command, and that command is called grub2-makeconfig. And once that's run, the changes get picked up, and when you get rebooting, again, you'll see those changes in the next boot cycle. We will go deeper into these files in the next lesson. Now, just like we saw with grub2 has an interactive boot. And when you get to that splash screen, you can hit escape and get in and modify things as need be. And you can see all those lovely commands that I've noted there. So go ahead, feel free to pause and read through those, but we're going to go ahead and move on and get moving forward. So upon completion of today's lesson, you'll be able to locate the grub file, and we'll also discuss the contents of grub files and directories. Demo time! Okay, so I don't know about everyone else here, but I like to learn by getting my hands in, getting my hands dirty, possibly breaking things. And so we're going to see a lot of images of things blowing up, things getting destroyed here as we go through the course. And that's going to be our cue to cut over to the demo environment and learn some stuff. So without further ado, we're going to go ahead and cut over to CentOS here. Okay, so here we are in our CentOS distribution. This is actually an older CentOS distribution known as CentOS 6. And it's a legacy distribution that we need to use because, well, grub is the legacy bootloader. So what we're going to do is we're going to navigate into the boot grub directory, which is where all the configuration files are going to be that we need to look at for looking at grub. And specifically, we're going to look at a file here called grub.conf. Now we can see all the files in the directory by running the list command. And I actually like using ls-al. That allows us to see a long listing of the files, and it also allows us to see any hidden files. So let's go ahead and run that. And inside of here, we can see that grub.conf file, but we also notice that menu.lst is pointing to grub.conf, right? So menu.lst is a symlink to grub.conf, and that's because grub historically wants to use menu.list as the default file, but in this distribution, in CentOS 6, the grub.conf file is the one that actually holds all the information we want to see. Now, I know from past experience that unfortunately, in order to get into that file, we have to run a sudo command, sudo edit, in order to get into grub.conf, and that's because that file is not viewable by anybody who does not have a privileged user account. So in order to get privilege on my user account, in order to edit that file or view it, I need to run sudo. I'm going to run sudo edit so we can actually edit the file if we wanted to. We're not going to do that today, but let's just go have a look. So we'll do sudo edit grub.conf. And then we're going to go ahead and specify my password so we can get in and escalate privileges. And now we can see the contents of this file. So the first thing we want to look at when we look at grub is devices and device naming, because it's a little bit wacky. What we notice here is we see things like HD00, or down here again, we see HD00. In Grub Legacy, all devices start with 0, and Grub actually can't distinguish between a SCSI drive or an IDE drive, so it just sort of generically uses the device identifier of HD, hard drive, for all devices. And the syntax for naming that device is device type, drive number, and partition number. So here we see HD00. Well, what that really represents is the first partition on the first hard disk, which in this system is dev SDA1. Now, there are also global settings that are used to identify operating parameters. Well, what are global settings? Well, these are things that we can see like default over here. Default equals 0. Well, it's 0 because it's used to determine the default OS we're going to load, and it's a 0-based index, which means that the most recent loaded OS we could use is actually 0, which means 1. It's the first one. But because the index starts with 0, it's always going to be 0. We can also see the timeout. Timeout equals 5, which is right below the default value here. And the timeout sets the time in seconds that Grub will wait for operator intervention, right? So when the Grub menu comes up, it's going to sit there for 5 seconds and wait in case we want to go in and edit anything or change the way that the boot operates. We can also see the splash image right below that. And this is used to define the image or background used on the Grub menu displays. So if you want to change the background to something fancy, you could do that by specifying a different path to a different image file there. Now, on this system, we don't have a password specified, but you could also have a password line that contains a plain text or encrypted password, and that would be necessary if you wanted to go in and edit any Grub settings or execute commands during the Grub boot process. You would need to specify that password before you could get in and change anything. So the last thing we want to talk about here is sort of this area right here. And we're going to talk first of all about the title. The title is what is used to define the available operating system. And we only have one here, but the title that we're looking at is this most recent one, 2.6.32. All right, and that actually specifies the kernel version. Now, the root down here is used to specify the location of Grub's root directory, or, /boot, which is where the operating system is going to be loaded. And as I said previously, HD00 is actually dev SDA1. The kernel line down here, it actually specifies the kernel file to load and how to mount the kernel. So VM Linux is kind of weird. What that actually means is that this is a compressed kernel file. And we can see that it's VM Linux 2.6.32, et cetera, et cetera, et cetera. So this is the kernel file, the compressed kernel file that we're going to load. And then we have information on loading it and how we're going to do so. We have information about the UUID that's used to identify the device it's going to load on. We have information about LUX, which we'll learn about later, and the language we're using, and that's a localization thing. We'll learn about that later as well. And then finally, we see down here initRD, some of the initRD settings. Well, initRD specifies the initRD file to use its initial RAM disk, and that is a file system that has executables and drivers we need to boot the kernel. So upon completion of this lesson, you will be able to locate grub2 files in CentOS and Ubuntu, and we'll discuss the contents of grub2 files and directories. Demo time. So let's move on over to our demonstration environment and take a look. Okay, so let's take a look at grub2 using the newest CentOS distro, which is CentOS 8. We can see that here, Rob at CentOS 8. And just from past experience, I can tell you that in order to go ahead and look inside of these files and even just list the contents of the boot grub2 directory, we need to become root. Now, normally I would not recommend doing so. Certainly if you can always run escalated privileges temporarily, but just to speed things up here, we're going to become root temporarily. And we're going to go ahead and we're going to take a look inside of the boot grub.2 or grub2 directory. So let's go ahead and do that. We're going to navigate to cd boot grub2, and then we're going to run an ls-al so that we can see the contents of this directory. And look, we see grub.cfg. Now this is the replacement for grub.conf that we had in grub. In grub2, it's called grub.cfg. And we can look at that file by just doing a less. So we'll do less grub.cfg. And inside this, well, the first thing we see at the top of this is a big scary message. Do not edit this file. Well, okay. Well, we see that it's automatically generated by grub2 make config. That command is used to generate this file, and it generates it using templates from the etc grub.d directory and settings from etc default grub. Okay, well, let's take a look at those files, right? So let's do less etc default grub. And what's in here? Well, this is pretty much what we were used to seeing before. So we see the timeout value, and we see some information about the distributor and console output, et cetera, et cetera, et cetera. So these are all kind of default variables that are used when configuring grub2. And we'll get more into this in a little bit down the road. Let's also take a look at that etc grub.d directory I was talking about. Okay, and inside of this directory, if we run an ls, we can see that it has scripts that we have here that are used to create the grub menu, different scripts for different purposes, and we'll talk about that in a few minutes. And we also see that we can create custom scripts here. So we see 40_custom. That's used to create custom scripts. And then once we were to create those custom scripts and maybe modify etc default grub, we can run that grub2 make config command to update our grub bootloader. So now let's go ahead and move over to Ubuntu. And if we look at Ubuntu here, we need to change directory to boot grub instead of grub2. That's just because things are a little bit different when you're discussing different distributions. So if you're talking about Ubuntu, even though it's grub2, you're going to find things in boot grub. If you're on CentOS, you'll find them in boot grub2. So let's go ahead and do an ls-al in this directory, and here we can also see our grub.cfg file. If we open up that file, we can see our big scary message again. Do not edit this file. It's automatically generated by, grub-make config. Well, okay, but we see that it still uses the templates from etc grub.d and settings from etc default grub. So let's take a look at etc default grub and see what's going on here. What's up with that? So if we get into etc default grub, we see that it says if you change this file, run update grub afterwards, update boot grub.cfg, this .cfg file we were just looking at a minute ago. And we can still see all the default values here, but this is kind of weird. What is this update grub? Well, remember in Linux, everything is a file. So we can actually find out what update grub does. And the first thing we're going to want to do is find out, well, what is update grub? Where is it? Where can we find it? And where can we interrogate it? So if we do a which command, it'll tell us the location of update grub, and that is in user sbin update grub. And we can do less user sbin update grub. And then what we'll see inside of this file here is that it's actually just running grub-make config, exec grub-make config, and the output is going to boot grub.cfg, which we know is that kind of default file that sets up the bootloader in grub2. So really the big thing to remember is if you are in CentOS, you're running grub2 everywhere, grub2 for the commands, grub2 for the directory path. But if you're on Ubuntu, you're going to be running grub. Don't ask me why. It just boils down to it depends. It depends which version of the operating system you're on, which distro you're using. So let's take a look, though, back at etc default grub. Let's get a little bit further into the weeds in terms of what is in here. Now, in etc default grub, as previously mentioned, this is going to contain our configuration variables. So we're going to see grub default, which indicates the default operating system to use. Again, that's a 0 value index. So the first entry is the one that's used. Even though it's 0, it starts at 0, so that's the first one. We'll also see the grub timeout style is hidden, which means that it's going to have a blank screen for the time period that is set for grub timeout. In this case, grub timeout is 0, so for 0 seconds it'll be blank, and then it'll start loading a splash screen, and you'll see the Ubuntu splash screen start up in this system. The grub distributor line is used when creating menu titles, so that describes kind of what we saw previously. It's going to describe different distributions, different operating systems that we're maybe running on this system, on this hardware. And grub command line Linux is used to set Linux kernel parameters. So we said the other piece of this puzzle, though, is our directory, right? So let's go and take a look at etc grub.d. And if we look inside of here, this is the directory that contains the scripts we use to build the grub menu in grub2. And I'll just tell you a little bit about these scripts. You can certainly take a look at them yourself if you wanted to navigate into this directory and you have a test machine you want to play with. But 00 header is the script that's used to load all those grub settings, those lovely configuration settings, those default variables we set in etc default grub. 10 underscore Linux identifies the different kernels that are out there, the Linux kernels that you could use to boot from. So as you update your system, you might have older kernels, you might want to roll back to those. Well, those are all found by that script and identified so that you can select them from the bootloader. 30 underscore OS underscore prober searches for non-Linux operating systems and puts the result into memories. So if for some reason you're dual booting Ubuntu and Windows, which some people do, you'll be able to see Windows as a boot option from the grub2 bootloader menu. And then 40 underscore custom. Well, as I said, this is a custom template that you can use. Generally, you would copy this template and then use that to create custom menu entries. Basically, we don't want to touch any of these except for 40 underscore custom, which we can copy and modify as need be. So upon completion of the lesson, you will be able to locate boot and EFI files in CentOS. You'll locate boot files in Ubuntu and know how to navigate the Linux file system to find both. Demo time. All right, so let's start with our CentOS system. Okay, so let's start with our CentOS system. We're over here, and let's go ahead and open up a terminal window and maximize the terminal window. And what we want to do is we want to navigate to the boot directory. So we're going to go cd boot, and inside of here, we're going to run an ls, or the list command, to display the files in this directory. And what we're going to see here are kernel images. Now, these are identified with the name VM Linux. For example, VM Linux-418 240.10.1. Yada, yada, yada. This is not a typo. The fact that it has a Z instead of an X at the end indicates that these kernel files are compressed with either BZ image or gzip compression. And we'll talk about compression later in the course. And we can see this if we run the file command. So for instance, we can do file on this one here. Let's copy that. And what we can see when we run that command is that it is a Linux kernel x86 boot executable BZ image. So this kernel file in particular is compressed with the BZ image format. And then also in this directory, we can see the init ramfs image files. For example, init ramfs 4.18.0-240, et cetera, et cetera, et cetera. And that will be associated with the kernel. And the reason for this is that the kernel decompresses and mounts that initial RAM disk that is specified by the bootloader. Now, another thing we can take a look at inside of CentOS is the EFI directory structure. And as I previously mentioned, EFI files can be found in boot EFI. So if we go ls here again, we can see our EFI file over here. And inside of there, we would normally be able to see some stuff, but since we're working in a virtual machine, we're not going to really see anything. We can navigate down into the directory. So for instance, if we go into cd boot and then cd EFI, inside of here, we're going to see the EFI folder. So we'll do cd EFI capital. And then we see ls is a CentOS directory. We can do an ls-al. And we can see that that's actually marked as a directory with rewrite execute permissions for the user root. So inside the CentOS directory, we can run an ls on CentOS as root. And we'll see the directory is empty, but that returns nothing. So it's just an empty directory here because this is a virtual machine. It's not running EFI. If the system were set up to use EFI for booting, there would be a FAT32 ESP. Remember, that's an EFI system partition that's mounted on boot EFI. And that partition would contain boot files used to control OS boot options on the system. And so, for example, you might see a file that would be called something like VM Linux, right? But it would say, instead of it being VM Linux, it would say VM Linux-Linux.efi, or you might also see something just called Linux.efi, and that would be the EFI ESP, EFI system partition that you'd be looking for. So now let's take a look at our Ubuntu system. And in here, we're going to go ahead and open a terminal window as well, and then maximize that terminal window. And we're also going to look in the boot partition on Ubuntu as well. And we're going to run an ls again so we can see all the boot files in this directory. One thing we're going to notice right away is that the kernel versions, the VM Linux files, are a lot newer, right? So we see 5.4.8 or 5.8.0-48- generic. And the reason for this is because Ubuntu was using current kernel releases and CentOS ships with a custom built 4.x kernel for stability and integrity. And then what happens is they backport changes into that kernel. So it's still secure, but for stability, they run an older kernel and then they just push fixes and updates into that older kernel from the mainline newer kernel releases. Another thing we can see here is we see VM Linux and VM Linux.old. So let's run an ls-al and see what that's all about. So we see the VM Linux here is actually just pointing to VM Linux 5.8.0-48 generic. That's the current kernel there. Versus VM Linux.old is a symlink, pointer here, an arrow to VM Linux 5.8.0-45. So that was the previous one. And that's just generally used by the boot process to basically be a shortcut to the current kernel versus the old kernel. So upon completion of the lesson, you will understand initrd and initramfs commands, and you will know when and how to use these commands. So let's get to it. Demo time. All right. So today we're going to cover the following commands: make initramfs and drake it. So with that being said, let's go ahead and get on over to our demo environment. And today we're going to start in Ubuntu. So here we are in our Ubuntu environment, and as you can see, we're still in the boot directory over here where we left off from our previous lesson. Now, the make initrd command is what you may see on the exam blueprint, but that command has actually been deprecated in my copy of Ubuntu, which is Ubuntu 20. So the command we're going to use today is make initramfs. And that command, make initramfs, is used to reconstruct the initrd file. So if we look here, we see initrd files, initrd.img-5.4.059 generic, right? And that corresponds to VM Linux, which is the compressed kernel 5.4.0-59 generic. These are file systems. It has the executables and drivers that are used to boot the kernel. So initrd boots this kernel here. And you may have to use the make initramfs command if you've added new hardware devices. Now, normally, those new hardware devices get picked up by the kernel upon boot. But if you're not planning to reboot the system anytime soon, and you've added some new hardware, if you're not planning to reboot the system anytime soon and you've added some new hardware, you may want to go ahead and reinitialize the hardware drivers using this command. So let's take a look at how you might do that. So the first thing we're going to want to do is run the command uname-r. And what this is just a process or a command that we could use to display the current kernel version that's running on the system. And we see that it's 5.8.0-48- generic. So one of the cool things we can do in Linux is something called shell expansion. And one of the great shell expansions you can do is actually running something like this. And what this will do is it'll pass it into a command that you're running. So the command we just ran will get passed into another command. So for instance, the first thing we're going to probably want to do is back this up, right? So we can do that using the copy command. We always want to back things up before we make changes in case something blows up and we need to revert that change back. So the first thing we want to do is copy this, and we always want to back things up because you may have to reboot or So what we're going to want to do with this is actually copy the existing initrd file, and we always want to do this in case we run into issues, in case we need to revert our changes or anything that we did. Remember, everything in Linux is a file, so if we have a copy of a file backed up, it's really easy to restore the file that we overwrote or made changes to that caused issues. And so we know that this file lives in our boot directory here, and these all start with initrd.image, and then they have a dash, and then they have the version. So this is 5.8.0-48 generic. We find that with the uname-r command. So by using this shell expansion here, we can just do this as a shortcut without actually having to type out that long number. And what we're going to do is we're just going to copy this, the cp command to copy it. We're going to copy it into root. Because root is owned by the root user, we need to elevate our privileges to do that. So we'll use the sudo command, and there we go. Now, if we do an ls, or actually let's do a sudo ls on root, we're going to see that we have a init rd image 5.8.048 generic. That shell expansion allowed us to put that in there without actually having to type it, this string right here. And we can also do an ls-al in root, and then what we can do is we can see the timestamp on it. So we see that this was created April 6th at 23:20, and if we do a date command, 11:20, that is, this is a local time here in EDT. 23:20 is the 24-hour time, so that is correct. We just created that file. It has been successfully backed up. So now, if we want to run make init ramfs, we can do that in our directory because we've already got a backup of this file somewhere else, and we can do that with make init ramfs-0. That's going to tell the command to output into this directory, into the boot directory, and we're going to call it init rd.img. We're going to use that same trick as before. We're going to say uname-r, and then we're going to use the existing kernel version, which we can use uname-r again, as the source to build this init rd image. And then if we hit enter, this will run. Oh, apologies. We actually have to run that as sudo as well. We have to elevate our privileges in order to run this command. We can run this now, and once it's done, we can take a look at the timestamp of the initrd file in this directory. Okay, and what we can do here is we can do ls-l boot initrd.image dash uname-r and hit enter. And what we can see is the timestamp on that there is 23:21, and we're at 11:21. So that file was just created. We successfully created a new init ramfs, a new initrd file actually. Okay, so that's what we would do over there in Ubuntu. Ubuntu uses initrd files. But let's go over to CentOS, and let's go ahead and get logged in here. And over here in CentOS, we're still in our boot directory. We can do an ls here. And what you'll notice is that init ramfs files are here in CentOS, and initrd files are used in Ubuntu. They're the same thing. The init ramfs is initial random access memory file system. It has the same job as initrd. It's a file system that has the executables and drivers required to boot the kernel. And just as we saw before, we're going to see a version of init ramfs with the same kernel revision here as we see for the VM Linux, the compressed kernel file. So 4.18.0193, we're going to see a 4.18.0193 here as well because they need to be associated. Every time you install a new kernel, a new init ramfs is created. So the Drake command itself will create an init ramfs image. And what we can do is we can run Drake. It's going to yell at us because it's going to say it cannot overwrite this existing version without force. But what we could do is we could create a new version of the file. And I'm going to do this as sudo. I'm going to elevate my privileges just to be safe. And what I'm going to do is I'm going to run Drake it, and I'll say new image dot image. Okay, we'll hit enter. And I'll type in my password here to get elevated privileges. And then we wait a couple of seconds here to about a minute, and we should be able to see that this file has been created. Okay, and now that has finished. And so we can do an ls in this directory. And now we will see right here, new image.img was created. Now, one of the other commands that you need to know for the exam is ls init rd. And what we can do is we can actually get information on that new image we just created. You have to run this with elevated privileges as well, but you can pass in the name of the image. And then what we can do is we can actually do a redirection trick. This is a pipe. And what will happen is this output here of the ls init rd of the image we just created gets passed over to less, and less is a pager. And what that means is it just allows us to see the output and then go up and down in the output using the page up and page down commands, hence pager. So this is going to run, and as it loads up here, it'll just kind of keep loading information. It's going to pause right here, and we won't see anything else until we get the page up or page down. But, it's just telling us information about what it's building. It's going to build this image, or this image was built in the CPIO format, and it puts information on the arguments that it used to build the image. It has information on all the different files included and the permission structure for those, and so on and so forth. And this is really far down in the weeds, but I just wanted to demonstrate what this command does. and some of the things that you may need to know for the exam about the ls init rd tool. One more thing that you might need to know with Drakit is that you can actually add specific drivers with the command. So for instance, if you wanted to add a specific driver with Drakit, you could do Drakit --add drivers. And if you knew the driver name, you could put the driver right here. And then you would just tell it what the image name is. So we could say new image.img again, for instance, right? And this would have to be run as, elevated privileges, but this would add that driver into a new image, and then you could use that image on your system. So upon completion of the lesson, you'll be able to understand boot commands and know when and how to use them. Let's get right to it with some demo time. All right, and in today's demo, we're going to cover the following commands. We're going to use grub2-install and grub2-makeconfig, and we're going to run both of these in the CentOS environment. So without further ado, let's go ahead and move over to the CentOS demo environment. And okay, a little bit of a fib here. We're not actually going to run grub2-install, and I'm going to tell you why. If you recall, on newer versions of CentOS, like CentOS 7 and CentOS 8, grub2 is already installed. So we don't need to run grub2-install. That would only be used if you needed to install a bootloader on a system or a device that didn't already have a bootloader installed on it and you want to install grub2. In our case, we already have grub2 installed. Remember, on a CentOS system, this is in boot grub2, and we can navigate into that. But first, we need to elevate our privileges. So we're going to become root. I need to type in my password in order to do that. And there we are. I just escalated my privileges. I became root as my user account with a sudo command. And now what we can do is we can navigate into boot grub2. And then we can run an ls, a list command, and we can see all of the lovely files that are in here. Okay, so what we're going to do is we'll actually go ahead and create a new copy of this grub.cfg file, right? Because remember, the grub2-makeconfig command is used to create that new configuration file, and it's going to use the contents of this boot directory. It's also going to use the contents of etc default grub, and we can take a look at that, etc default grub. And remember, these are just kind of our variables that are stored here in this file. It's also going to use the contents of the directory, etc grub.d. And these are all script files. Remember, we looked at this, we saw this in Ubuntu, but it's pretty much the same here. We have script files that are used to build and configure that grub.cfg file. And again, the new configuration is created with grub2-makeconfig. But before we do anything, let's go ahead and make a backup here. We're going to say, let's copy boot grub2 grub.cfg to boot grub2, and we'll call it grub.cfg.older. All right, and now if we do an ls on boot grub2, we can see grub.cfg.older. Okay, and if we wanted to now, what we can do is we can make a modification. So let's go ahead and modify etc default grub. What we're going to do in here is we'll modify the timeout. So instead of it being 5 seconds that it waits, it's going to wait 10 seconds. And the way that I did this, I went into this using Vim. And to go ahead and modify anything in Vim, you have to hit I for insert. There are a few other ways you can kind of get around in here, but that's the most common. So I just navigated to where I wanted to be and hit I for insert. And then I can start typing. I want to change 5 to 10. And I'm going to escape. And then I'm going to type :WQ. :WQ will write and quit out of this file. And we can run less on this file again. And we can see that our grub timeout is now changed to 10. So that's good. So now when we run grub2-makeconfig, it's going to pick up the changes we just made. And then we could use those changes to update the grub.cfg file. And I'll show you how to do this. So we're going to run grub2-mkconfig. All right. And I'm actually using something called tab completion so that I don't have to type out the entire command. You can start typing and then hit tab and it'll complete the command for you so that you don't have to type everything. So we're going to do grub2-makeconfig space -o for output. And we're going to tell it, we're going to put this in our boot grub2 directory. And we'll call this one grub.cfg.newer. Okay. And it's going to create the grub configuration file, and it's done. So let's do an ls, and now we can see grub.cfg.newer right here. And what we're actually going to do is we're just going to copy this right over our existing grub.conf file. That's why we made a backup, right? If anything goes wrong, we can always revert it. So we're going to go ahead and do copy. And we're going to do copy grub.cfg.newer, and we're going to move that over grub.cfg. Yes. Okay, and now if we reboot this system, we should be able to see that it takes 10 seconds for the window to go by. Let's give it a shot. Now this is a VirtualBox image, so it's going to reboot here. You're going to see a VirtualBox message, and then it should come up into our boot menu. And if you sit here and wait, you can see it counting down 6, 5, 4, 3, 2, 1. So that change did go in place. We were able to change that to 10 seconds, and we were able to get our system kind of reconfigured there in terms of the way our boot operates. So upon completion of the lesson, you'll be able to understand what a kernel panic is and describe the utilities that are used to handle one. So a kernel panic is essentially a preventative measure. And this is what happens that when the kernel detects an issue, and it does so in order to prevent any kind of loss or corruption of the system itself. Some common causes of a kernel panic can include some configuration issues. You could have problems with the applications running on your system. You might have a hardware failure, or you might have driver issues. A buggy driver can sometimes cause a kernel panic to occur if it accesses some memory it's not supposed to be using. So the kernel panic in kernel uses the kdump utility, and that's used to save the crash dump in memory. Now that requires that you have some system memory set up or reserved for storing that information, and that's configured in grub using crash kernel. Crash kernel is used to set up and reserve a certain amount of memory, system memory, to write the output of a kernel panic so that it can be used to determine what exactly happened when the kernel panic occurred. The kexec utility is used by the kdump to boot into a second kernel when the system crashes. And this is where you can interactively get in and kind of see what's happening. It preserves the system state, and you can analyze the crash dump using the crash command.